Exactly did SpaceX accomplish this, and how did they manage to land 70-meter tall rockets, weighing in excess of 500,000 kilograms, precisely on a 50-meter wide landing pad after they are launched more than 70 kilometers into the atmosphere at speeds exceeding 8,000 kilometers per hour? When SpaceX performs a launch with the Falcon 9, the rocket separates into two stages in the Earth's upper atmosphere. The second stage of the rocket carries the payload into space, while the first stage booster returns to Earth and lands at a landing site for reuse. The booster is programmed to follow a precise flight path back to Earth, and it must autonomously perform a series of controlled maneuvers in order to maintain that path and land vertically on the landing pad. The exact flight path depends on whether the rocket is landing on a floating drone ship in the ocean or on land, and for landings at sea, there's the added complexity of ensuring that the drone ship is in the correct position when the rocket touches down. However, the greatest engineering challenge by far is building a rocket capable of performing the maneuvers that are necessary for controlled descent and landing. After stage separation occurs, the rocket booster reorients itself and performs a boost back burn to achieve the proper trajectory towards Earth. During the descent, it performs a re-entry burn, which is used to reduce its velocity. As the booster approaches the landing site, it reorients itself again so that it is in line with the landing pad, it deploys its landing legs, and it performs a landing burn to bring its velocity to zero as it touches down on the pad. Cool. The Marlin rocket engines of the first stage booster are gimbaled using hydraulic actuators so that the direction of thrust can be adjusted. This is a method of thrust vectoring that can be used to control the orientation of the rocket, both within Earth's atmosphere and outside of Earth's atmosphere, where aerodynamic control surfaces, such as fins, are ineffective. The Falcon 9 is equipped with a total of 8 nitrogen cold gas thrusters that are mounted towards the top of the first stage. There is one pod on each side of the rocket, each containing 4 thrusters. Like the gimbaled main engines, the cold gas thrusters are used to control the orientation of the rocket. They are particularly useful for the flip maneuver after stage separation because of the large lever arm between the thrusters and the rocket's center of mass. They are also used to control the rocket at times during the flight when the gimbaled main engines are shut off. Since the first stage must perform 3 separate burns after stage separation, it is necessary for the main rocket engines to be reignitable. The engines of the first stage booster have therefore been designed so that they can reignite in the upper atmosphere at supersonic speeds, as well as in the lower atmosphere at transonic speeds. The onboard computer receives data from the INS and GPS in real time and checks this information against the pre-programmed flight path. If the computer detects any deviations from the flight path, then it instructs the rocket to adjust its orientation and velocity as necessary. Number 5. Deployable landing gear. In order to perform vertical landings, the Falcon 9 is equipped with 4 lightweight landing legs that are deployed using high-pressure helium just before touchdown. Each leg is constructed from carbon fiber and aluminum and contains an impact attenuator for particularly hard landings. The total span of the deployed landing gear is approximately 18 meters, and the entire landing system weighs less than 2,100 kilograms. Number 6. Deployable grid fins. 4 titanium grid fins are mounted at the top of the first stage booster and are deployed during the rocket's descent back into Earth's lower atmosphere. The fins are aerodynamic control surfaces that are used for precise control of the rocket's position and orientation prior to landing. The 4 grid fins alone are primarily responsible for the incredible 10-meter landing accuracy of the Falcon 9 first stage booster.